you have these algebra review forms. My plan for a week from today, so it'll be Tuesday for you all, and those who are listening to this lecture at home, and in a different cohort, it'll be Wednesday for them. We have a two-part test coming up. Part 1, we get to work on all together. And then you get it all done, and you get to use it. You get to keep it at your desk with you and do the other part on your own when you can cross-reference what you have. You can use your own computer. You can use just not PhotoMath. You can use your phone if you have the Desmos app on it, or you can use one of my Chromebooks. And I just want Desmos app is all we'll be using. That'll be 1 week from today. Sound like a plan so far? Oh my gosh. Okay, so we'll just close that because it's not doing me any good. It's just sitting there spinning. All right, so just taking a quick look, my friends. Is there anything on that front page? And it looks like it goes 1, 2, 3, 4 down on a column, then 5, 6, 7, 8 the next column, and then at the bottom row is 8, 9. At least my numbering is correct, even though it's all over the place. That's okay. Take a look at there. Could you, with Desmos or any other math source, be able to identify where it crosses the x and the y axis? Any mins or maxes? Deal with any asymptotes. And you don't have to worry about the window being -10 to +10, especially when you're using Desmos, because it's easy to zoom in and zoom out real fast. Is there anything on there that you want me to go over a little bit more in detail for you just on that front page? Yes? What kind? All kinds. Okay. So there are 3 types of asymptotes. So if the degree on top is greater than degree on bottom, so an example of that could be like x to the 3rd plus 2x to the 4th plus, let's make that to the 3rd, plus x plus 1 over x squared plus 3. This degree, let's make that a 2 then. This degree here is bigger than this degree. So however my highest exponent is on top, being is bigger than on bottom, this is going to have something called a slant asymptote. Okay? And a slant asymptote deals with what shape is my graph following as I go way out towards infinity. Okay? And in order to find the slant asymptote, you're going to have to use long division. Now, this is a different concept. If you get stuck on it, please ask me. Okay, even on a quiz. So I'm going to do long division on steroids. So I'm going to go x squared plus 0x plus 3 into x to the 3rd plus 2x squared plus x plus 1. Does everyone feel comfortable with that? I added a 0x in there for a reason. I want a placeholder. We still with me on this adventure? Okay. So I have 1, 2, 3 terms. So I'm going to go over 1, 2, 3. This is basically where we're going to start dividing. So what I'm going to ask myself, what do I need to multiply times this x here, or this x squared by, to make it x to the 3rd? X. So I'm going to go x times x squared. That gives me x to the 3rd. X times 0x is 0x squared, which is still 0. X times 3 is 3x. Then I'm going to subtract these. So x to the 3rd minus x to the 3rd, those cancel. 2x squared minus 0x squared is 2x squared. X minus 3x is minus 2x. And then I bring my 1 down. Does that math seem okay so far? Okay, my next step. What do I need to multiply that x squared by at the very far left of my board? What do I have to multiply x squared by to make it 2x squared? 2. So 2 times x squared 2 times 0x, 2 times 3. Give me a little more room. I'm going to subtract 2x squared minus that. Those are gone. That gives me negative 2x. That gives me negative 5. Okay? Can I multiply x squared by anything to make it negative 2x? No, so I'm done. So this here, y equals x plus 2, is my end behavior, or my slant asymptote. Okay? So let's put this down. Let's add a screen. So I had y equals x plus 2. Agree? So what's happening here is if I graph this, x plus 2, up 1, right 1, as my graph goes way, way out here in the x direction, it's going to follow that black line. It's going to get real close to it. As I go way, way out this direction to negative infinity in the x direction, my other part of my graph is going to follow the other line. Now, my original problem was this. So what does that graph look like? I don't know. It's going to look like, kind of like, I can tell you at the ends of it, it's going to probably come real close to it like this. Could come real close to it like this, or it could be on this side, or it could be on this side. That's what the ends are doing. What's going on in the beginning? That kind of stuff. Okay? Now, that's just talking about the slant asymptote. That takes place anytime you have your degree on top bigger than your degree on bottom. It talks about what's going on at the infinities. What graph will I be following? Okay, so that's item number 1. So that's the slant asymptote. The vertical asymptote takes place where the denominator equals 0. So if I had, like, let's get fancy, f of x is equal to 3x plus 7 over x squared minus 4. The degree on top is less than the degree on bottom. I don't have an end behavior asymptote. I have a vertical asymptote, so I would take this and say, well, x squared minus 4 equals 0. Add 4 to both sides, or I could have factored it. If I take the square root, I have to remember there's a plus or minus 2. So these are my vertical asymptotes, which what that means, plus or minus 2, if I were to graph it, I have a vertical asymptote here, and I have a vertical asymptote here. What does my graph look like? Well, it could look like this. Inside, it could look like this, or it could look like this in some shape or form. So that talks about the vertical asymptotes. It's where the denominator is equal to 0. Yeah. So I will probably ask you on the group portion of the test, I'll have this. Tell me, and I'll say, what is the slant asymptote? So you have to do the long division as a group. The next one will say, what's the vertical asymptotes of this one? As a group, you all got to figure it out. And then there'll be one saying, what is the horizontal asymptote, which is the third one? So this happens in two things. When the degree on top equals degree on bottom. And there's two scenarios here. You can have this scenario So this just means it kind of streams all out. So what you do is you kind of look and you say, okay, the degree on top and the degree on bottom, they're equal. Happy about it? Okay. Let's put a number out here. Let's put 6 out here, and let's put 7 over here. So my horizontal asymptote on this one is going to be y equals 6 over 7, which is a horizontal line at about 1. That's when that's taking place. The other horizontal asymptote is when the degree on top is less than degree on bottom. So let's say we had x to the 5th plus a whole bunch of other stuff over x to the 7th plus, so that's just a big old string of stuff. If this takes place, if degree on top is less than degree on bottom, then y equals 0. So the x-axis becomes your asymptote. So those are basically all of your asymptotes taken into account. Does Desmo show it? Yes. We did talk about yesterday, there are times that you could have a graph that do this. You could have, say, some vertical asymptote here. We could have one here. Actually, let's undo that bottom one. Let's do like an asymptote here. We could get a graph that does something like this. So notice this does indeed cross the asymptote, but it follows it along here. It follows this one, follows this one, follows this one. So it is possible from time to time, you know, by definition, an asymptote is something that you approach that you never get to, except for sometimes that does happen. But you see, you get to use Desmos, so Desmos would show you when that did happen. Okay? Did I answer your questions on asymptotes? Okay, what else do we see, friends, on that front page? Feel good? Let's flip over to the second page, so 10 through 14. Notice all the answers are there. Is there anything there? A classic problem is like number 14. Number 14 is a height equation. That's if you throw something up in the air and it comes down, if you just drop something, or if you throw something downward. So that's what that kind of problem does. And again, you would just graph it. You would say y equals, you change your t's, make them x's, and go in that way. Okay? So let's have a little fun. You'll have a phone with me, right? Or with you? Somebody check with Google or Siri or whoever you ask for the free fall equation. Somebody do that for me. Find me the free fall equation. And they might use G at T, H at T. They might use some. Plus like V naught T. Does that say something like that? Okay. Plus H. That's basically the free fall equation. Okay? What that is that's the equation that you use. G is whatever planet you're on, whatever the gravitational pull on that planet would be. Here on Earth, it's negative 9.8 meters per second squared. So that's the acceleration due to gravity. Okay? Some people might say it's, well, let's do our dimensional analysis. Let's do this. Did anyone ever do this? Let's convert this into feet. Still have your phones out, I hope. I see them on your desk, so I know they're there. My friends, how many, I want to convert this into meters per second squared. How many, 9.8 meters, or let's do this first. We're doing dimensional analysis. How many feet are in a meter? How much? 3.37 inches? 3 feet, 3.7 inches? Is that what you said? Okay, so 3 feet, 4 inches. Okay, 4 inches is the same thing as 4 over 12. 4 over 12 is the same thing as 1 over 3. Agree? 1 over 3 is 0.33. So 3.33 is going to be that. So I'm going to get rid of meters. So I have 1 meter is 3.33 feet. Is that okay? What I can do here is I can now cancel meter with meter. So my answer is now going to be in feet over second squared. Okay, I need your help. 9.8, it's going to be negative. What's 9.8 times 3.33? 32 point what? So let's call it 32.2. Sound good? Ooh. Yes. 32. Okay, that sounds good to me. Okay. So that means I can plug this in for G. What is half of negative 32.6? Okay, so negative 16.3 t squared plus v naught t plus h. Okay. This comes into a perfect time to put a life story of stirrup in here. All right. So for some odd reason, my mother and father, as well as my friends' mother and fathers, always felt it was fine for all the 16-year-old boys to hitch up our vehicles to their boats and drive their boats to the lake. This was a good idea to our family. Here, we're going to let you take something that in the water has a prop going fast enough. And any of you take my med class? You took it. Remember that orthopedic surgeon had that leg and it had all the slits in it because they got in a fight with a boat rotor? Yeah. So, this is already a good idea. Here, we're going to let you guys take boats. And I already told you, my dad, he had his Boston Whaler, had 3 outboard engines. So it had 3 4-cylinder engines, outboard engines on the back of the boat. You could have, and you had basically three throttles. Yes, you could throttle one and only have one engine go. That's no fun. Yes, you could have 2 engines go. Made it a little bit more fun. Let's have all 3 props going at once because we go fast. Now that boat pulled a lot of water skiers. We would just start dropping water ski lines out in the back and saying, okay, just let's not cross lines. So you're kind of got your skiers or scurfer, and depending upon who is on what, out there and they're floating in the water. And you'd come around and you get the boat and you try and get the water ski line close to them. And so they swim and grab onto it and kind of get, I only use one of the motors, just get it pulling forward. So I start dragging a little bit. So they're all holding on, dragging. So you ready? Hit it! All 3. And I mean, that boat would just pull people up like that. If you were on 1 ski, you were up immediately. It was no drag. If you're on 2 skis, you might as well just be standing on the water. But we used to go to Apache Lake in Arizona. Apache Lake is on something called the Salt River. The Salt River flows out of the White Mountains, which is on pretty close to the New Mexico state line. But this river flows down. Arizona, being it's a dry desert, kind of like Colorado is a high desert, and it's also dry. We like to dam up the water because you didn't know when the next rain was coming. So this was the water that people used to, the Salt River Project used to get all of the water to us. And we say, the water tastes great. Tastes just like the lake. And it did. So there was a place at Apache Lake which had some awesome cliffs to jump off of. Now, when I say awesome cliffs to jump, we'll come back to this equation. Awesome cliffs. There's this one cliff. So here's the water line down here. Okay? And you had this cliff that came out like that. That was kind of good because when you jumped off, you jumped in the water. Being I had a depth finder on the boat, when you had the depth finder, the water, depending upon how high the lake was, we had it up to 60 feet deep. So the nice thing is, you weren't going to hit the bottom. If you did, you were falling from outer space. So it had one cliff, and this first cliff was about 10 feet up. And then the mountain kind of continued behind it, and then you had this one, and this was about 30 feet up. And then you had one up here, and it had this protruding rock like this. So you get up here. We called this the three screamer. Okay? And we called it the three screamer for a few reasons. One, it was way up there. When you got up there, the people down in the boat were way down there. Honestly, we would dare people. Can you scream 3 times on the way down? Meaning, ah, 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 boom, hit the water. It was a 3 screamer. So we weren't sure how high this was, but you would jump off this, and you had a lot of time to think about what was going on in life on your way down. Yes, we had to make rules. Make sure when you enter the water, your legs are together. If you can't figure that out, ask one of the fellas why. You don't want your feet apart when you hit the water because it's going to hurt. And, I never had the guts to do some of the things that some of my friends did. I would just jump off this cliff feet first, try, you're doing this on the way down and into the water. And when you hit the water, you want to make sure your arms went straight up because you don't want to smack the underside of your arms because that also hurt. But we'd have friends, they would dive off this. I'm like, yippee! It's like, make sure you make that diamond because you don't want your head breaking the plane of water. And then we had people that would be doing flips off of it, intentionally or not. Hopefully they were landing feet first. But this is a 3 screamer. This was about 3.1 seconds that you would free fall before you'd hit the water. Okay, so let's keep that 3.1 seconds in mind. Let's go back to the other equation. My thing there is in seconds, yes? I would say that our initial velocity would be 0, so that'd be 0t, because we weren't necessarily jumping up and then down. It was basically if you do a launch like that. So you weren't really elevating yourself, you're just horizontally leaving the side of this cliff. Okay, so I have this equation. I'm going to use, someone write this down for me so I can y equals 16.3 t squared plus h. Write that down because I'm going to go to the next board. You got it? Ready? Okay. What was that equation? Okay. So we would jump off this cliff, and it was a 3 screamer. We timed it, and it was about 3.1 seconds. Okay, let's just take this back to 3 seconds. Let's figure this out. What is 16.3 times 9? Because 3 squared. What do you get? 16.3 times 9. Divide 146 by 3, would you, real quick? Just put in perspective. So it was basically from the 50-yard line to the end zone of the football field. Vertically. Think about that. Think about 3 seconds. Ready? We're at the edge of this, and we go to jump, and we jump right now. Hit! You got a lot of time to think about your way down, don't you? So that was kind of fun. So, being I was a math nerd, I kind of like, oh, this is fun. We can figure out how hard. And so, but those were some just fun things. That's what that kind of equation goes to. Okay? Yeah, I will tell you, there were people that would be up here, and they'd be looking down and doing this with their legs. It's like, you guys dancing? No, I'm scared. Well, jump. No, I'm scared. Well, jump. No, I'm scared. And then they'd start to climb back down. Now, the nice thing is, it was easy to climb up, because it's always easier to climb up things than climb down. You'd watch them climbing down. They'd be slipping. They'd, bump into one of the jumping cactus. The jumping cactus basically have little hooks on their things. So it grabs onto you, and it hooks into your skin, and then the whole clump of this thing is against your skin. So what do you do when it's against your skin? You grab it with your hand. Now it's stuck to your hand. Oh, it was funny. You watch people, they were just maiming themselves. They're getting down, their hands all bloody, their arms bloody, or their leg, wherever the cactus hit them. And it's like, if you just jumped, you wouldn't have to deal with that. But I was scared. Yeah, but it would only take you 3 seconds to get down here. Now we're actually having to, do first aid. Like, here, rinse your arm off in the lake. Yeah, that should be good. So just funny stuff. All right, so my friends, why don't we give you all the opportunity to work on 1 through 14. And so that will be, and I will take 1 through 14 for points. So it's only the first page. So graphing review number 3, 1 through 14. You have the rest of the period to work on it. Ask me about it. That all we got? Man, I spent that much time. I'm sorry. I didn't mean to waste time telling you about water skiing out at the lake. We had fun times, though. You know what's the best part about that boat? So if I was in my dad's boat and I'd be following another boat, that other boat would be in front of me. That other boat creates a wake. That other boat couldn't go as fast as my dad's boat, even though my buddy Matt Owens' boat had a 351 Cleveland, 8-cylinder engine in it, so it was a good engine. He couldn't go as fast as 12 cylinders coming behind him with 3 props in the water. So we'd be all in the boat, and there'd always be, oh, I'm going to get in the front. So, you're going to get wet? Okay. So people would get in the boat, and getting inside that wake. You're in that wake line like this. Here's this boat going that way. Here comes me in my boat with 3 engines going. I could get that boat out of the water, going over the wake, with all 3 props spinning. So you'd watch the RPMs go from like 4,000 to like 12,000 instantly because there was no resistance to water. And that boat, it'd go, man. Somebody was watching over us as we were kids. So get those problems done for me for next time. My friends, take care of one another. Have a great day. Yeah.